So, this is BSM 201. Now we will discuss the improper integral. Integration, all of you know from the very 11, 12 in your syllabus, you have the integration. Now, improper integral, all the topics or all these concepts are not there in the improper integral. Just you have to know that this is your a to b fx dx definite integral. We will represent by this integration a to b fx dx. This is the definite integral as there are two limits. If any one of this limit is infinity or both of this limit is infinite, then we call this is a one kind of improper integral type. Now, basically we are talking about the gamma function. Gamma function, we will generally denote it by capital gamma. Now, capital gamma is defined on the function n that 0 to infinity e to the power minus x, x to the power n minus 1 dx, where this n is obviously greater than 0. Now, if we take here n equal to 1, that means gamma 1. So what will be the gamma 1 formula? Integration 0 to infinity e to the power minus x. Put there n value 1. So x to the power 1 minus 1, x to the power 0 means 1 dx. Now, look at this limit of this integration. Upper limit is infinite. So that means this is an improper integral. That means gamma function is a special kind of improper integral. How we can solve this type of problem? We have to take in the place of infinity any variable. Here we take x. Now, x as a variable, we can integrate in our previous way. So, integration e to the power minus x by minus 1, 0 to capital X, right? Now, put there capital X, put there 0. Now, as we know that if x tending to infinity, e to the power x tending to minus x tending to 0. So, first we will put the limit values, then we will solve for this. So, as x tends to infinity, this term will be 0. Ultimately, we will get it is x independent, so that will be plus. So, gamma 1 value is 1. I think it is clear to everyone. Now, we will go to the next. This one is the first property. Next one is the gamma in. We can change it to gamma n plus 1. Gamma n plus 1. That means 0 to infinity e to the power minus x, x to the power n plus 1 minus 1 dx. That means this is your e to the power minus x, x to the power n dx. Now, there is a first function, second function. So what we can use there? We can use there the bypass integration, taking x to the power n as your first function and this is as your second function. So this is your x to the power n minus e to the power minus x. This is within bracket. After integrating, formula is 0 to infinity, right? Minus, as there is a minus and there is also a minus for Bipers integration formula. So we can write down this plus 0 to infinity n x to the power n minus 1 e to the power minus x dx, right? Now, if you put there infinity, so that value will be 0. If you put that 0, so that value will be 0. As a resultant, this whole term will be 0. Now, look at this part. N, this is obviously your gamma n. So, this one is the another formula. Gamma n plus 1 equal to n gamma n. And gamma n plus 1, if this n is an integer, in this way we can find out this is n factorial. This is actually the corollary part of this. This is for n equal to any number, and this is for any integer. N equal to any integer, right? Another one part is and this is the another formula where n is between 0 less than n less than 1. N is between 0 to 1. Now, using these formulas, we will solve a problem, and this one problem is very, very important in the gamma function. Minus infinity to plus infinity e to the power minus x squared dx. Now, this type of problem, how we can solve it? First, you can see that this x square is which type of function? This is even function. How we can identify a function is even or odd? If we put x square in place of x square, if we put minus x square, that will give you the same value, x square. So f of x, if we considered it f of x and this is f of minus x, both are same. So we call it a f is a even function, right? If this is a even function, then for definite integral property, we can use this is twice into 0 to infinity e to the power minus x square dx. Clear? Now, this is 2 into, now 0 to infinity, we will try to make it into the form of gamma function. Back of the mind, our tendency to take it into that format, gamma function form. So here is a x term whose power is 1. There is x square whose power is 2. So first we have to put x square equal to z. That means 2x dx equal to dz. Right? Limit is as it is 0 to infinity e to the power minus z. As if we put 0 to infinity square, same it is infinity, so 0 to infinity. Now, here we have to put dx value. Dx value is dz by 2x. Now, what is the value of 2z? Value of 2z is 2 root over, value of 2x is 2 root over z. So, these 2 cancel out each other. Now, if we consider it, that is e to z to the power minus half dz. Now, can we write down it? Obviously, we can write down this minus half. We can write down this half minus 1. That means this is your gamma half, right? And gamma half value, this is also, you can prove that what is the value of this gamma half. Just we are back to the previous slide. Here you can find out the, from this slide or this particular property, if you can put the value of n equal to half, so gamma half, this is also gamma half, that means pi by sine pi by 2. Sine pi by 2 value is what? 1. That means this is pi. So gamma half square equal to pi. That means gamma half equal to root pi. So just put that the value and you will get gamma half equal to root pi. That is the answer. So this kind of problem in gamma function is very, very important. Then find out the answer of this kind of problem, integration 0 to infinity e to the power minus 4x dx. For more video, you have to connect it with this channel. For today's, the class is over.